All right, so in this video, we're going to go over how graphing applies to kinetics, and really we're going to be looking at the integrated rate law. What's going to be important in this video, though, is being able to look at a graph to determine what the rate order of the reaction is, and also trying to derive what K is based on that graph or the data that's given to you. So when you graph concentration against the time, you can actually use the slope to determine what the rate is. So the rate will be the decrease in concentration of a reactant divided by the amount of time it happens in. So anytime that we have a reaction and it's just beginning to progress, you should see the reactant start to decrease with respect to time. And then that's going to give you the rate of the reaction. So 0, first, and second order look very different when you graph them. So if I graph just the concentration versus time, I should see in every single reaction that the concentration decreases with the reactant. But in a 0 order reaction, I have the straight linear line going down. In a first order reaction, I'm going to see the line going down, but it's curved. And then a second order reaction looks very similar to the first order, except when I graph the concentration versus time, it's going to be a much steeper curve. So if I were just given a graph and I was told it's a concentration of the reactant divided by versus the time, I could just simply look at the graph and determine if it's 0, first, or second order. All right, so with a 0 order reaction, so this is our 0 order graph right here, the concentration versus time. I should see a straight line going down. So if I have a straight line going down and I graph concentration versus time, that should be a 0 order. So the slope of a straight line is going to be constant. Well, in this case, that is going to give me my rate. So my rate with a 0 order reaction is constant. So if I were to take the rate and graph it, if I were to take the rate and graph it versus concentration, I would see a flat line. So right here, our slope is constant. Our slope happens to be the same thing as the rate. If I were to graph that, I should get a flat line. Now with a first order reaction, if I graph the concentration against time, I should see this curve right here. Well, if I take the rate, so the slope of the line here, well, since it's curved, it's constantly changing here. So my rate will be changing. So if I graph the rate versus the concentration, I should see a straight line going up. So basically, as my concentration is changing, so is my rate. So basically, as my concentration increases, so does my rate of my reaction. So if with a second order reaction, it looks very similar, except the curve if I plot the concentration versus time, the curve is much steeper. So if I were to take the rate, which is the slope of this line, and plot that against the concentration, this is what I'm going to see. I'm going to see a line going up, but instead of it being straight, it's going to be curved because the rate is not going to be constant here. So it's going to vary. The rate will vary depending on the concentration of the reactant. So this is the important piece right here. With a second order reaction, the rate's going to vary depending on the concentration of the reaction, or of the reactant. All right, so if you remember, there's an equation that you were taught a long time ago in one of your math classes. This is the straight line equation. It's very important, and it's used in chemistry all of the time. If you rewrite your rate law as this format, then the slope can be used to determine K. So you can actually you take your rate law, you rewrite it into this equation, and you can use that to determine what K is. And the way that we rewrite the equation depends on the order of the reaction. All right, so for a zero order reaction, this is my straight line equation. This is what it looks like. So you're actually given some of these equations on your reference sheet of the AP test. So basically, you don't need to derive it. I'm not going to ask you to do that because you're going to be given most of these equations on your reference sheet. What's important is that you know what to do with the equation, and then also what does it mean if you graph it and you see this. All right, so when I look at a zero order reaction right here, this is the equation I'm going to have. The concentration at a certain time is equal to negative K multiplied by that time. So maybe it's like 5 seconds into the reaction, what's the concentration? Plus the initial concentration. So if I know this equation right here and I'm looking for a concentration at a certain time, and I know what the initial concentration is, I can just simply plug it into the calculator and solve for that concentration. Now, the other important part of this is that if you graph the concentration versus time, you're going to get a straight line for a zero order. So the slope is equal to negative K. Now, if you have a first order reaction, your equation looks like this. So again, you don't need to know how to derive it. This is actually given to you on the AP reference sheet. So if you were to take data from a first order reaction, and if you take the natural log of the concentration of A and graph that versus time, you're going to get a straight line going down. So here, our slope would also be equal to negative K. So what you're going to see for this particular reaction, if you were to take the natural log of the concentration of A and graph it with respect to time, you're going to get a straight line going down like this. The slope of this line, since it's going down, should be negative. Well, K will be the slope of the line. But of course, K should not be negative, so the slope is equal to negative K. Now, if you remember, this is a first order. A zero order, if I just plot just the concentration versus time, I already have a straight line. But if I take the natural log of the concentration of A and plot it with respect to time of a first order, I'll get the straight line. All right, so for a second order reaction, this is our equation, and this one is given to you on the AP exam. You don't need to memorize it. You don't need to know how to derive it. So if I'm looking at a second order reaction, if I take 1 divided by the concentration of A, so the inverse, and I plot it with time, I'm going to get a straight line, but this time it's going to be going up. So the slope would be equal to K. So when you get the straight line, so if you manipulate your data a little bit, when you get your straight line, that's important because then I can get K, and then I can also know what type of order reaction it is. All right, so just to kind of sum up what I was just talking about. If you graph data and get a straight line, you can determine what order the reaction is. So if you simply take your data, take your concentration and plot it against time, and you get a straight line, it's a zero order. If you take the natural log of the concentration versus time, it's a first order reaction. If you take 1 divided by the concentration of A, so the inverse versus time, and that gives you a straight line, that would be a second order. So if it's asking you to determine the order of the reaction, and you're just given concentration versus time, if you were to plot it and manipulate the data, as soon as you get that straight line, that will tell you what order reaction it is. So if I simply plot concentration versus time, straight line at that point is 0 order. But if it doesn't give me a straight line, then I can take the concentration and manipulate it. I can take the natural log of that versus time. If I get a straight line at that point, it's first order. If it's still not a straight line, I can plug it in, manipulate it again. So take the inverse, and if I get a straight line at that point, it's second order. Okay, so let's look at some data. So I'm going to go over how to actually use your graphing calculator in class, but this would be the kind of data you would see. It's different than the data that you saw in the last video. It's just concentration versus time. So in the last one, I was given a rate plus a concentration. I'm not given rate here, just time and concentration, that's it. So what you do here is you can take your calculator and plot this. So let's say that you take the concentration and you plot it versus time. Well, it's not a straight line. So if I plot this versus this and it's not a straight line, it's not 0 order. So that means it's either first or second. So what I need to do now is I need to take the concentrations that I was given in the data. Let's go back. And I take the natural log of those. So I take ln of A and then get some data points. And then once I do that, I can plot this versus my time. And if I do that, I get a straight line. Okay, so if I get a straight line at this point, that means if I'm taking the natural log and I get a straight line, that means that it will be a first order reaction. So at this point, if I wanted to, I could use my calculator to get the line of the equation, and then I get K. And again, I'm going to show you guys how to do that when we get to class